Hey guys, I want to take us on how to write differential rate laws. First and foremost, what is rate of reaction? The rate of reaction can be defined as the change in concentration with time. So that's the rate of reaction. For this first order reaction here, of course we know that our rate very proportional to concentration. I use block brackets in chemistry, it means concentration. So how do we write rate of reaction for this series of reaction here? These are equilibrium reactions. The two are equilibrium reaction, and this is a consecutive reaction. So let me add one more, 6. And we have a parallel reaction. Here going to form B following first order reaction, and here again going to form C following second order reaction. Okay, 2. So how do we write differential rate law for the first reaction here? I said earlier that rate is proportional to concentration. Therefore, for the first one, rate is the same thing as change in concentration of A. Put the bracket, then A in the bracket with time to vary proportional to concentration of A. But to remove the proportionality sign, we have to introduce a constant. Therefore, our rate, which is the A all over the T, equals to K, this K here, 1 A. Forget the bracket. But this, we are writing our rate in terms of A, which is our reactant. We're writing our A in terms of reactant, which is A. And since A is decreasing with time, let me give an example here. We have a cup of water that is being heated. At time t, let's say the water is at this level, this is our A, and we have another bucket, another cup rather here, and we have a lid here, a cover. At time t, when the reaction starts, time t is equal to 0. When we have not started heating the water is at this level. When at time t, let's say 2 minutes, the water would have reduced to this size. As it boils and evaporates, it condenses here to form B. So B will be increasing with time because the thing is falling here. Meaning A will be decreasing with time, then B increasing with time. Let's say this is our B. To increase it until A finishes. So, since we know that our A is decreasing with time, so if we have to write the rate in terms of A, we have to indicate that A, which is our reactant, is decreasing with time. So we put negative side here, negative sign here or here, but not both sides. So I can put my here. So it has a negative sign in either of these place. So for the second one, we follow the same step. No, before the second one, if we want to write the rate of reaction in terms of this, it will now be the B, the T, to be equals to K1A. This K, this rate constant will always multiply the concentration of the reactant, always to multiply the concentration of the reactant. So but we don't have any negative sign either here or here. So it's the same thing with the rate of reaction of reactant. This is for the product, which is B. So for the second one, we want to write in terms of the two reactants A and B. So it is the A, the B, and the T rather, which equals to the B, the T equals to minus K2A B. A multiplied by B. So there is negative sign here because both of them are reactants. So for this equals to this and this equals to this. So that's why for the product, which is C and D, to be the, for the number 2, to be the C position of the C, the T equals to this D, the T equals to K2A and B. Remember, I told you either you are writing the rate of reaction in terms of product or reactants, it will be the rate constant, either K1 or K2, will be multiplying the concentration of reactants, either 2 or 3 or 1. In this case, it's 2. So that's the rate of reaction for the first, the second one. For the third one, this for the second, this for the first. For the third equation, up here, this is forward reaction, this is backward reaction. For the third one, I've broken the reaction into 2. A plus B going to form C, then C now forming A and B back. For case 1, A plus B going to form C, following forward reaction. For the forward reaction, so the rate of reaction in terms of the reactants A and B will be the A, the T equals to the B, the T to be equals to minus KF A concentration of A times concentration of B. There's my negative sign here. So the A dt equals to this, the B dt equals to this. There's negative sign here because A and B are reactants, as I explained here earlier, that the rate reactant will be decreasing with time. So for C, for the case 1, for C in this case, to be the C, the T for the differential rate in terms of C, since C is the product being formed, so it equals to KF A B. There's no different. The only difference here, this is the product. The only difference here is that between this 1, 2, 3 is that there's negative sign here. There is no difference. So we are writing, this is showing we are writing in terms of reactant. That's why you have negative sign here, and this is showing we are writing in terms of product. Since 3 and 4 are the same thing, we follow the same mechanism. So let me proceed to number 5. Number 5, A going to form B, then B forming C. This implies that B is an intermediate. It quickly broke up to form C. So A going to form B follows first order reaction as we have written earlier. So in terms of our reactant, the A, concentration of A, it is differential rate law in terms of the reactant will be minus K1A. This is reactant. And for B, to be the B, this is case 1, and this case 2. For the case 1, the B, in terms of product, all over the T equals to K1A. Remember, this is the only difference is that this one has a negative sign. The negative sign can be here and can be here, but it's not both sides. So from here we see that the negative sign is here. For case 2, this was case 1. For case 2 here, the B, the T equals to minus K2B, because B is the reactant here forming C, and the C, the T equals to K2B. Told you earlier that the rate constant will be multiplying the concentration of the reactant, and this is the reactant in this case. This is the reactant in this case. That's why you have A here, we have B here. But the only difference is that for this is that there's no negative sign beside this, beside the rate constant. So for the last and not the least, this kind of reaction, I'm going to break it down into two. For this case 1, as written earlier, the A, actually the differential rate law in terms of reactant here equals to the T, the T equals to minus K1A. Remember, the rate constant will multiplying the concentration of reactant. Either you're writing in terms of reactant or we're writing in terms of product. So if we're writing in terms of product, the B, in this case 1 now, the B, the T equals to K1A. No negative sign here. This is a block bracket, please. No negative sign here or here. There's no negative sign. For case 2, these are reactants A forming C. So now with the A, the T equals to K2A minus here. Minus K2A. These are reactants forming product here. So for the product, the C, the T equals to K2A. So you are either writing in terms of reactants or products. These are products in this case, and these are reactants. This will be the same. The only thing difference is that there will not be negative sign for product here. So write the differential rate law for this in terms of A and B. Thanks for watching. You can subscribe for more video at youtube.com/simple learning. Bye bye.